Energy, work, power that we're doing today. You need these two pieces of papers. Cut that one out into every little box. Do not cut this paper. Okay? Once you've cut the formulas out, set them to the side. This is a foldable. So we are going to be folding. It's very simple. Those two vertical lines, fold on the two vertical lines. Fold on the two vertical lines. Okay? Okay, here we go. So, energy, work, and power, these are each variables. So, with your pen or pencil, those horizontal lines that you can see through the paper, draw them in so you can see them really well. Okay, so the one that has the symbol E, which variable do you believe that one is? Exactly. The variable energy. What about the W?
Work.
Work. And the variable that's represented by P? Power. Okay? Notice they are all uppercase. Uppercase E, uppercase W, uppercase P. Okay? Energy, work, power. All those uppercase. All right. Let's talk about units of measure. Units of measure for energy, work, and power. For energy, it's called joules. Joules. All right? That's pronounced like joules. Joyas. All right? That's how you pronounce it. That is the last name of a French nerd. All right?
What's your name? What's his first name? Diamond.
I don't know. All right. Now, interesting little fact, work has the same units of measure. Joules. Okay? Physics, when we're talking about work and physics. All right? So, what do you suspect the symbol is for joules?
J.
Very good. Uppercase J. Now, power has the units of watts.
Like the battery? Like the light bulbs?
All right. Yes, like light bulbs. Also named after a nerd. Last name. This is technically a lowercase w. All right? Notice the W for work is uppercase. That's the formula symbol, and this is the unit symbol, watts, lowercase w. Just be very careful when you're reading those W's. Make sure you're thinking whether it's watts or whether it's work. Try not to get confused. All right, so let's talk about energy, which is measured in joules. Energy is stored work. When I say energy, what do you think of?
Like lightning. Electricity.
Like electricity, lightning. All right? Running.
Yeah, people and stuff.
People moving around. Little kids with too much sugar, right? Hyper. Okay, this is energy as we see it from a perspective of physics. Okay? Energy is stored work. Okay? Well, to understand that, you have to understand what work means. Energy can cause forces. So that's something you could probably relate to. Forces. We've talked about force, push or pull. Energy can cause forces. All right? And energy can do work. Now, you can simply say energy is work. Now, you cannot say work is energy, but you can say energy is work. Okay? All right. So, work uses energy. Work can create energy. Do we see this really close relationship here between like work and energy? It might be helpful to kind of think of work and energy like two sides to the same coin. It kind of depends upon what your perspective is as to whether you're talking about energy or whether you're talking about work. Okay? So, kind of helps give you a little bit of perspective there. All right? Now, strict definition, work is a force applied through a distance. All right? So some force is applied and something is going a distance. All right? In order for work to be happening, the object must move. The object must move to do work. If the object doesn't move, there is no work being done. Okay? So we have here a formula, W equals FD. W stands for?
Work.
Work. Is equal to, F is?
Force.
Force. Multiplied by? Distance. Okay? So work is the force times the distance. The more force, therefore, the more work. If I increase the force, I will increase the work. If I increase the distance, if there's more distance, how does that affect the work? Sorry. More work. Okay? More force means more work. More distance means more work. Okay, so an example I like to do with this one. My daughter, who's 5 years old, likes to help me take the groceries from the car into the kitchen. Okay? Considering she's 5 years old, I give her a box of cereal, and then I send her to the kitchen. She takes her box of cereal very proudly to the kitchen. And then I turn around in the car, I put 3 bags of grocery on one arm and grab 2 gallons of milk in that hand, and 3 bags of groceries in the other arm and grab 2 gallons of milk in that hand, and haul it all in right behind my daughter. Okay? We both go the same distance, but my movement is requiring much more force because I'm carrying many more groceries, so I'm doing a lot more work than my daughter is. Does that make sense? Okay? Now, similarly, I could, when I was in high school, no, when I was middle school, I lived in town, and I had a backpack, and I put my backpack on. And I would walk my distance to school. I had another friend who also walked to school, but I lived much closer to the school. I lived like half a mile away, and my friend lived like a mile away. So my friend did a lot more distance, even though our backpacks probably had about the same weight. So my friend did more work. Fair enough? Makes sense? All right. Now let's talk about power. Going back to that watts. Okay? Try and remember power is measured in watts. Sometimes it might be helpful to remember the little phrase, how powerful is your light bulb? If you, of course, associate light bulbs with watts. It helps. All right. So, power. If you look carefully, look for a moment at its formula. P stands for what? Power. Is equal to the work divided by time. So now we're talking about work, but how it's related to time. So, power is about how fast the work is done. Okay? So how quickly the work gets done tells you about how powerful or how much power is being used. So, faster equals more power. Okay? If I do more work in the same amount of time, that is still an indication of more power, because more work is being done. Now, here we're going to look at an inverse proportional relationship. An inverse relationship. The less time it takes you to do something, the faster you do it. The faster you do it, the more power. Okay? So less time means more power. More work means more power. Okay, so back to my daughter and I doing groceries. Okay? It takes us the same amount of time to walk to the kitchen, because she won't let me walk past her. That, of course, would be insulting. So we take the same time it takes to walk from the car to the kitchen. But I'm doing more work. Therefore, I am more powerful. Does that make sense? I'm requiring more power. Similarly, if we were both to carry a box of cereal, but I get to the kitchen faster, well, let's try this way. A gallon of milk. That would take her time. That would slow her down. So a gallon of milk each would be doing the same work, but I'm going to get to the kitchen faster. Okay? Because, again, I'm more powerful. I've got more power. All right? I'm doing more power. Make sense?
Yeah.
All right. That little piece of paper, our nice little pretty foldable, we're going to go ahead and glue it in. So put some glue on there. Now careful where you glue it in. I want it glued to the left side of the page because we got other stuff to put on this page still. Okay, so glue it in to the left, because you want space to be able to glue the formulas on the right. Okay, so make sure you glue it to the left. And obviously glue it so you can still see all of your lovely notes. Nope. The formulas are going to go to the right. This is going to go on the left. Sorry, zoom out a little bit there. All right, on the right side, let's go ahead and glue in the first of our formulas. Work equals force times distance. Give yourself a few lines of space above it.
That goes with energy.
It's not necessarily going with energy, it's just glued to that side. I just need space for it. Okay, so let's label it. Work. The W stands for work. F is what?
Force.
Force. D is distance. What are the units of measure for work? Joules. What are the units of measure for force? Newtons. And what are the units of measure for distance? Meters. All right. All right. Power is work divided by time. Glue that in. Give yourself a few lines of space above it. P is for power. W for work. Can't forget, make sure you have the right one, the correct one. T for time. Units of measure for power are
Watts.
watts.
1.21 gigawatts.
All right. Units for work are joules. And my units of measure for time, what do you suspect those are going to be?
Seconds.
Seconds it is.
Is it seconds?
Yes, it is. All right. Now, for those of you who have impeccable algebra skills and are highly observant students, you're going to look at this next formula and you're going to look at it and go, oh, I see. For everybody else, I'll explain. Let's take this next formula, give yourself a few lines of space, and go ahead and glue it in. Take a look at it. Ponder what you are looking at. Ponder that formula.
Force times distance divided by time. Understood.
All right. So, it's a formula that solves for power, right? But we already have a formula for power. But it's not the same, but it's kind of similar. But instead of W, we have FD. All right. So, our two formulas from above, power is work divided by time, and work is force times distance. If we take this relationship and do a substitution, so work is equal to force times distance, right? That means we can replace work in this formula with FD. Do you guys see that?
It's a replacement.
And you bring that together, and now you have this formula.
I see.
Does everyone see where that came from?
Is it the same thing?
Okay. So, this is basically just taking these two formulas and putting it together. Okay? So if the problem provides you with force, time, and power, you can solve for the distance. Fair enough?
Yeah.
Okay. So that, I don't always teach that, but I figure that's a little helpful extra detail that might help you. All right. Now, as in any time we are dealing with physics and we have formulas, we often need to be able to rearrange those formulas. So, if you need to rearrange the formula, what is the way I encourage you to do it if you lack algebra skills?
Triangle.
The magic triangle. So, W equals FD. Triangle for that. F and D are side by side. That puts W on top. Okay? Power is work divided by time. Triangle. W over T in the formula, so that puts W on top, T on the bottom, and that leaves P to go on the bottom. If you look at those two formulas, those two triangles carefully, they both have W on top. So that might be a helpful little hint reminder. If you want to go ahead and fill in the other values, so F is equal to W over D, and D is equal to W over F. All right? W is equal to P times T, and T is equal to W over P. Okay? So, there's your rearrangement of the formulas. Help you when you're working out problems to work through those. Okay? That's the basics on energy, work, and power. Now you get to do the worksheet that helps you practice what you have learned.